Hello, good morning students. Welcome back to online classes of pulse and digital circuits. So in previous class we have seen about your clipping circuit, that too with only one part. Okay, so one independent source, right? We have seen the clipping circuits with one independent level. Along with that one we have seen the different kinds of clipping levels, like with reference level, without reference level. Okay, clipping above the reference levels, shunt series. Okay, now in today's class we are going to see about your next topic that you are having here. This one is your clipping at two independent levels. So whatever we have discussed yesterday was a clipping at one independent level, and you have seen series clipping, shunt clipping, series clipping with reference level, shunt clipping with reference level, and series and shunt clipping with and without reference levels. And I hope you are all clear with that one. And when we have told about the one independent level, it means that we have only one diode or one what we can say voltage series, okay, voltage source. Now we are using two independent levels. So and the clipping is done at two independent levels. It means that we are using two diodes, okay, and this resistor will be followed up here by two diodes, which out of one that will be in your forward bias condition and other will be in your reverse bias condition. Fine. So this shows, it means that you will be having a parallel and also a series or a parallel series arrangement that can be used in a double-ended limiting at two independent levels. So that's the reason we call it as clipping at two independent levels. Now if you see here the transfer characteristics, when you are applying the sinusoidal input voltage, okay, the input what I am applying here is a sinusoidal input. So how you will be getting the there in the last class when we have seen clipping at one independent level, right, and we have seen series and shunt part and their figures also, but you had only one breakdown, correct? I hope you all remember what is the breakdown voltage or the breaking point over there. So we had only one break point here, but here in this part where we are using two independent levels, you will be having two break points, and one will be at the output voltage should be equals to the input voltage, that is first reference voltage VR1, and the second break point will be occurring at when you will be having the condition output voltage is equals to input voltage, and that will be negative part of your reference voltage. So that are the your what we can say breakpoint that will be occurring. So if you want, I'll show you for one independent level where we have seen the breakpoint. See here, this was your first initial topic that we have discussed about your clippers, correct? Then this is your clipping circuits. How you will be the combination of your clipping circuits? We have said that there will be a combination of diodes, resistors and reference voltage. That is a series combination that we have seen. Again we have seen a network which is consisting of many diodes, which one we are seeing now, okay, two independent levels. So we are using two diodes over here. Then next that we are going to see is your two emitter coupled transistors, which will be operating as your differential amplifiers. So in that one, very first we have seen about your series combination of diode, resistor and a reference voltage, and we have also seen that you will be having a breaking point or a break point that will be occurring at your reference voltage, and this reference voltage will be different for different materials, and we have seen it will be 0.2 volts for the germanium kind of material, and it will be of 0.6 volts for the silicon, and your reference voltage is very small when compared to the what we call input voltage will be very small, or the break point voltage will be very small with reference to your reference voltage, and that particular point can be neglected. So these are the points where you will be having the breakdown points, okay. So I hope you are all remember what this breakdown actually. Breakpoint will be occurring at the reference voltage VR. To the left of the breakpoint, that is Vt is less than T, then the diode will be acting as a reverse bias condition, and if it is right side of the point, then it will be acting as, that is condition Vt should be greater than of VR, then your diode will be operating as your forward bias condition. Correct? This was your shunt or series clippers by using one independent level. Now as we have already said that we will be using a network that will be consisting of many diodes, then you will be having a resistors and a reference voltage. So that is a topic that we are seeing, right? See here, now we are using many diodes, that is for example we are using 2 independent levels. You can go for the 3 or 4 also. So clipping is done at many diodes using a resistor and a reference voltages over here. So this may be either series or either parallel, or they may be both in the series or parallel arrangements, like it is shown here. Okay, series and parallel arrangement, these both are in parallel and it is series for this one. Fine. So this is to be called as a double-ended limiting at 2 independent levels. You are having 2 independent levels here. So this parallel arrangement is called as your clipping at 2 independent levels. And you have to see the transfer characteristics, which are shown like this. When your input voltage is greater than that of your first reference voltage, we are having 2 references voltages here. If input voltage is greater than your reference voltage here, then your output V0 will be getting as output as VR1, so this one. Because this diode is in the forward bias condition, so this will be short circuit, your current will be flowing. So you will be getting it will be as an open circuit, so no current will be flowing from the input part. So the condition is your first diode will be on and this D2 diode will be off. So it is in on condition, so there is no current flow from here. Okay, this will be open circuit. So that's the reason what happens, you will be getting output V0 is equals to VR1. Now the condition is that minus VR2, second reference voltage, is less than the input voltage, and that input voltage is less than your reference voltage 1. So minus VR2 is less than Vi and less than VR1. So what happens here, the condition here, D1 will be off, along with that one D2 will also be off. And what is the output that you will be getting? So these both are in the short circuit, you will be getting the output, that is your V0 is equals to Vi when the diode status are D1 and D2 both are in the off condition. Now comes to the third point, or the third condition, when input voltage is less than that of your second reference voltage. Okay, this is second reference voltage minus VR2, input voltage is less than this one, then your diode D1 is in off condition and D2 will be in on condition. If it is in the on condition, so you will be getting a short circuit over here. So your V0 is equals to minus VR2. So what happens here, from here the current will be stopping up to here, because it is an it is an open circuit, so it won't be flowing from here. So you will be getting an output V0 is equals to minus VR2. So these are the transfer characteristics that you are having for your clipping at 2 independent levels. Let's see the diode clipper which limits at 2 independent levels. Fine. First condition, when Vi is greater than VR1, D1 will be on, D2 will be off. Then minus VR2 less than Vi less than VR1, output will be V0 is equals to Vi, and diode 1 will be off and diode 2 will be also off. When condition is your input voltage Vi is less than that of your second reference voltage, then your output voltage will be equals to the second reference voltage, and in that particular condition your first diode will be in the off condition and second diode is in the on condition. Let's see the figure that you are having. See here, it is a piecewise linear characteristics that you are getting, correct? So this is your piecewise linear transfer curve when you are applying the sinusoidal input voltage from here, okay, and the corresponding output that you have got is this one. So this is the sinusoidal input. In this part, this is the first condition, this is the clipping part. You are having the slope 0 here in this part when your diode 1 is off and diode 2 is on, this one. Diode 1 is off and diode 2 is on. Here your slope is 0. Here also see in the clipping condition where you are having the clipping condition when diode 1 is on and diode 2 is off. Here also you are having the slope S is equals to 0. D1 is on and D2 is off. So these particular parts are your clipped off. Now see the transmission region when you are applying the input. See this is the input voltage that you have applied. So from here it is 0 slope. So a clipping region. So this particular part is clipped off. Now comes to this part where you are having slope is equals to 0. From here minus reference voltage. Okay, this is plus R1 and this is minus VR1. So this particular part, the what we can say, input voltage less than that of your reference voltage. So this particular part, so it is greater than here. So this particular part is clipped off. So your input voltage here is less than that of your reference voltage. So here it is less than, so this particular part is clipped off, it is greater than this particular part is clipped off. Your input voltage, this is your input voltage, is greater than your VR1, so this is off. Your input voltage is less than your VR1, so this is will be cut off. So this particular part, here you can see the reference voltages, VR1 first reference voltage and minus VR2 second reference voltage. So when you are applying this input sinusoidal wave here, so these parts will be clipped off, and this particular region where both the diodes are off condition, then you will be having a transmission part. Your output will be equals to the input. So this particular region is called as your transmission region, right? So this is about your clipping, which is done at two independent levels, here and also here. So this is how you are doing the clipping at two independent levels. Now see, here you have given a proper explanation how it will be working. The two level diode clipper, which is already shown in the above figure, this is your above figure. So works as follows: when Vi input or the V in is greater than that of your reference voltage VR1, this is if you consider Vi, if it is greater than of VR1, then your diode 1 is in on condition, okay, this particular part, and diode 2 is in off condition, and equivalent circuit is shown like this. Okay, so this is the first one, diode 1, which is the condition Vi is greater than of VR1. It is clear? Can you see here? Equivalent circuit for Vi is greater than of first reference voltage. So your diode 1 will be in the on condition, it will be shown, and diode is in the off on condition, it is off. So the output V0 will be equals to VR1, because it is passing, the current will be passing from here. So this reference voltage will be given as an output. So that's the reason your V0 is equals to VR1. Now see the second condition. What is the second condition? When Vi is less than that of your minus VR1. Okay, equivalent circuit, Vi is less than of minus VR1. Here the diode 1 will be in the off condition and diode 2 is in the on condition. So if diode 2 is in the on condition, then what is the output that will be occurring here? V0 is equals to minus VR1. Okay, VR2. So V0, so your output V0, because the current will be passing from this particular part, this VR2 will be given as the output. That is your V0 is equals to minus VR2. And the slope of this transfer characteristics for these conditions will be 0. You will be getting slope is equals to 1 when both the diodes are in off condition. Okay, so that particular this particular circuit which we have seen in the 2.7, this one is called as your slicer circuit, because you are slicing these particular parts. Okay, you are slicing it off. So this particular circuit is called as your slicer, because the output contains a slice of the input between two reference levels, that is VR1 and VR2. So looking at the input and the output waveforms, we can say that this circuit may be used to convert a sine wave into a square wave. Yes or no? If we go on somewhat clipping, so what we can directly, this can be used as a square wave. See this part? So we can also say that this particular circuit can be also used to convert your sinusoidal wave into a square wave. And if the condition VDI or V0I is equals to Vm, and its amplitude of the input signal is very large compared to the difference in the reference level, the output can be a symmetrical square wave. So we have to see the condition, your input diode, first diode voltage is equals to your a proper of minimum reference voltage, and if the amplitude of your input signal is very large compared to the difference in the reference voltage, amplitude is this one. If this one is very large, this particular part is very large when compared to the reference voltage, then at that particular point we can use this circuit as for a symmetrical square wave generator. So two Zener diodes in series opposing may also be used for these double-ended clippers. So instead of normal PN junction diodes, we can also go for the Zener diodes here. Okay, if the diodes are having identical characteristics, then the symmetrical limiter is obtained. So some double-ended clippers and their transfer characteristics and their outputs for sine wave inputs are shown here. So I have shown some. Similarly, as we have seen some of the outputs for your single-ended clippings. So we have used single-ended clipping also. I'll just show it once again. Right? These are the things that we have seen, right? These are some single-ended clipping circuits where we are having the shunt clippers with a positive peak, without reference level, then shunt clippers, negative peak without reference level, then series clippers, and we have also seen series clipper with positive clamping with reference levels. These are with reference levels above or below, and these are without reference levels. Yes or no? Now we will be seeing how you are going to have some clippings of your different voltages, some double ended clippings we will be showing here, some of the parts. See, very first one that we are seeing, two level clipping using the Zener diode. Okay, so in this particular part, when it's a condition when your VI is less than that of your reference voltage or the Zener diode breakdown voltage that you are having, at that particular point here this Zener diode will be in the on condition. When it is on, so no reference voltage will be coming from input voltage will be coming, so you will be getting V0 is equals to minus VI. Or the reference voltage here, and if it is in between your the reference voltage and the Zener diode voltage here, your Zener diode will be off, and V0 is you will be getting a short circuit over here. So if you are having short circuit, there will be a path, then you will be getting output that is equals to input. And if VI is greater than that of your Zener diode voltage, input voltage is greater than that of this voltage, then your Zener diode will be breaked off, and you will be getting V0 is equals to Vz. Okay, now see the second part. This is a two level clipping for a Zener diode and two level clipping using one Zener diode. So these are the transfer characteristics. You will be getting a transmission region when you will be your Zener diode is off, and it will be breaking at less than that of your reference voltage, and it will be on condition when greater than that of your reference voltage. Here in the opposite one, two level clipping using a Zener diode. Okay, here you are using one Zener diode, here you are using just using a Zener diode. Okay, one more than that one. Okay, this is in the forward reverse bias, this is in the forward bias. So that will be having on when you are having below the reference level, so it will be off at the transmission part, and it will be breakdown and above that part of your reference level. So this is how your clipping will be done. So we can say that this can be used for your symmetrical square wave generator. So by seeing these outputs, we can say that this circuit may be used to convert your sine wave into a square wave. Yes, this is a square wave, this is also a square wave. So you are able to generate a square wave. This is the condition that we have seen just now. Two level clipping using the Zener diodes. Just now we have seen the two level clipping by using the PN junction diodes. So this is a two level clipping. We are using a Zener diodes, where first condition that you are having when VI is less than that of your Vz of the breakdown voltage of your Zener diode plus that of your reference voltage. So Z1 will be breaked off and Z2 will be on, and you will be getting V0 is equals to minus Vz plus V delta. So in this particular part, you will be having the transmission region, and when you are having this reference voltage is below than this one, then your Z1 will be breaked off and Z2 will be on, and here above this one, above this particular part or above Vi is greater than your Vz plus V delta, then your Zener breakdown, first Zener breakdown voltage will be on and second will be off. So in these both, when both the diodes, Zener diodes are off condition, then that particular point you will be having a transmission region. I'll show you the Zener normal PN junction diode also. See here, these are the transfer characteristics of your normal diodes. PN junction diode. So below the reference level, you will be having first diode will be off, second will be on. So here slope is 0, here also your slope will be 0, and in this particular both the diodes are an off condition. This is your transmission region, and here at this particular point your slope will be is equals to 1. So if it is slope equals to 1, this is the transmission point, and these particular parts, okay, above the reference level and below the reference level, these are clipped off, and you will be getting this proper wave, and this proper wave is nothing but your square wave. So we can say that this two level clipping can also be used to generate the square wave when you are going to give input as an sinusoidal wave. Yes, so we are giving a sinusoidal wave here as an input, but as an output you are getting a symmetrical triangular wave. So square wave. So we can say that you can this double ending clipping can be used to generate your square waves. If I go to see one more part of your clipping, two level clipping using the diodes and two positive reference voltages, then you will be having a square wave, but in terms of pulses. Okay, two reference voltages and two PN junction diodes we are using, but they both are having the positive references, so we will be getting above this point. Okay, about your origin you will be getting the positive references. So if you are going to have two reference voltages above the if you are having two positive references voltages, then this is the condition that you will be getting. So if I see, if Vi is greater than less than that of your second reference voltage, then your first diode will be off and second diode will be on. So what is the if first diode is off, what is the second diode is on, then you will be getting output V0 is equals to VR2. This is on. So second condition, when VR2 second voltage say reference voltage is less than that of your input voltage, less than that of your first reference voltage, both the diodes will be in the off condition, then the output will be directly input will be directly flowing to your output. So your V0 will be is equals to Vi. Then the third condition is your V input is less than greater than that of your first reference voltage, then your first diode will be in the on condition and second diode is in the off condition. So the output will be V0 is equals to VR1. So here you see both you are having both positive reference voltages. So here above the origin we are having this positive clipping. So this part is clipped off and this particular part is clipped off. So this is the output you will be getting, and in this particular part V1, in between V1 and VR2 you are having transmission, right? Between V1 and VR2, see this part. So that's the reason you will be having transmission at this particular point only, and these both at this point we will be having slopes as 0 and 0. This is clipping region, this is the transmission region. Okay, so here is only transmission region when your input is flow to the output, only at this particular part. Now comes to the second one, two clipping levels using two diodes with two negative references. Obviously below the origin you will be getting two reference voltages. These are the conditions, please make a note. And in this particular part only you will be getting slope as is equals to 1, and between these two negative references your current will be flowing. So that is called as your transmission region, and these particular regions where your D1 is off and D2 is on. So this particular part you will be having as a clipping region. So these positive points will be clipped off in the negative part. Fine. Okay. I hope you are clear with this part. Two level clipping using two diodes with the two negative references, two positive references, and using one references and Zener diodes. Now see the last one that you are having, double ended series biased clippers. You are using a biased circuit. If you are using series biased circuit, then what is the condition? Okay, if you are having the input voltage which is less than that of your minus V2, this is the second diode voltage, then at that particular point your first diode will be off and second diode D2 will be on, and here in this point your input output voltage will be equals to input voltage plus V2. What is V2? What is diode D2? This is in your on condition. So you will be getting this input voltage along with this the second diode, second reference voltage. So this is your output. Second condition, when minus V2 is less than that of your input voltage and less than that of your V1, then diode 1 and diode 2 both are in the off condition. So it is an open circuit, no current will be flowing. So your V0 will be equals to 0. Because there is no reference voltage at near which is followed up by the resistor also. So for that condition your output voltage is equals to 0. When you are having the third condition, when your input voltage is greater than that of your first diode voltage, okay, so here what you will be having, your D1 will be on condition and D2 is off. So which one will be flowing? V1 will be flowing. So what happens here, then V0 is equals to V1 minus of V1. Vi minus of V1, because your Vi is greater than that of your first diode voltage. So that's the reason your output voltage will be V in minus of V1, and this is how your clipping will be done. Where you will be doing the clipping, this is V1 and this is your minus V2. So you are doing the clipping in this particular whole part. V0 is equals to Vi plus V2. So in this particular part, Vi plus V2, this is the part, and this is your V0 and this is your input voltage. So this is the input voltage that we have transmitted, and this is the output. After clipping this particular parts, you will be getting the outputs in this part. So this is the condition where your transmission is done. Okay. and this particular this is the condition where your output is completely 0. You won't get any kind of outputs. So when it is D1 is on, D2 is off, you will be getting this part, and this particular part is clipped off, and D1 is on and D2 is off, so this particular part as an output you will be obtaining. And in D1, D2, these are the completely clipped off conditions. This is complete clipped off, so there is no output voltage here in this part. So this is first part. Okay, Vi is less than of minus V2. This is second part. Okay, and this part is completely when your D1 and D2 both are off condition. Here D1 is off, D2 is on. Here D1 is on and D2 is off. Here in this particular point, what is the condition? D1 and D2 both are in off condition. So this is how your clipping can be done. So this is the part where we are showing the double-ended series biased clippers. You are doing the clipping when you are having double-ended or two independent sources, and your series you will be having a biased clippers. So I hope you are clear with this part. Okay. So this was about clipping at two independent levels, right? So we have seen how this clipping will be done with the two independent levels where you are having series, parallel, and both the circuits. So I'll wind up the class here itself. If you are having any doubts, please do let me know. Thank you.